Moving on. Surface area and volume. Not going to spend a whole lot of time on this one. There's really not a lot of explanation to be done. You're just finding volume is always the area of your base times the height. And surface area is just the area of all of your surfaces. A couple of big things I will say. Cylinder, remember your surface area, you have to include this laterally around part for the surface area. You can do that by taking the circumference times the height. For a cone and a pyramid, remember it's finding the volume is the same as finding one for a prism or a cylinder, but you have to divide by 3 instead. Lateral surface area of a cone also is that pi times the radius times the slant height, pi times r times L. We've written all these down. Everything is on Schoology, all these formulas, and so I would go in there, if you haven't already, put them on a toolkit. I want you to have to memorize everything. Oh, so I'm knocking stuff over. Whoa. Seriously? A sphere is one we haven't done a lot of practice with, but surface area and volume both on here for that. All you need is the radius, 4 pi r squared for the surface area, 4/3 pi r cubed for the volume. But yeah, not a whole lot to say on here. It's pretty self-explanatory with the review guide. Just be careful with your, like, what shape your base is. Like, this one's a little different. Be careful with what height you're trying to find. Your volume, it always has to be the straight up and down one. But for something like this, if you're finding the surface area, you're going to want to use this slanted height. You'll have to do that by making this triangle. Right? Always try to find a right triangle to make. If you don't know what a side length is, there's probably a right triangle to be made. All right. I believe almost the last page. Maybe I'll try to get this one done in this video, because almost all of these on number 13 are more of these circle properties. Just be on the lookout for those. Again, I have that on Schoology. Just trying to find the picture that goes along with it, and then just solving it becomes an algebra problem afterwards. So with these ones, just keep an eye, put those on your toolkit. Absolutely need to put those on your toolkit. If you come during the test and you don't have these on and you're wondering what the formula is, I don't really have much for you. You should have them on your toolkit. Again, they're on Schoology. If you don't have them written down already, they were on the board. But for number 14, area of a hexagon, we've done a bunch of these types of problems before. Again, you don't even need to draw the shape itself. You really just need the triangle that's going to be in the center. And so with a side length of 10 inches, we've got a side length of 10. We are looking for the height. Can you pick something else to run into? So you need to find the height using some tangent properties. Just are never leaving me alone, huh? Can't just give me 15 minutes by myself, huh? And no, we're just going to eat the carpet instead. Right? There's nothing there. You're eating the carpet. You're eating the carpet. So by taking the tangent of your angle, solving for x, solving for that height, and then, of course, remembering to, I see so many people stop after finding the height of the triangle. Keep going, find the area of the triangle by doing this, base times height divided by 2, multiply by how many you have, and you'll get your final area. All right, last page. With these problems, I would really suggest not even looking at what I'm asking you to find, but see if you can write down as many values as you know here. So before even looking at, I need mn, see if you can go through and write down all the angles that you don't have, all the angles and arcs you don't have. Like on this, it's not done, but I know that's 70. Like I know that this has to be 110 because this all is 180, so this would be 110. And then I can go back in later and find the ones that I need. And I think it just makes your life a little easier. You're not having to go back and forth. You can just get this all done, then worry about which values you need. Number 16, maybe a little weird to see, but a big theme with some of these circle ones, a lot of them use a diameter to try to get some things done. So a couple cool things happen when you have a diameter in the circle. One is that both arcs on either side will equal 180 degrees. And so if I know that this is 68, this would have to be 112. And same thing on the other side. This is 118, this would have to be 62. So the, geez, Randy, what do you want? You just want to be pet. Oh. So both will have to be 180. Another thing that you can notice is that if there is an inscribed angle going from both parts of the diameter, it's always going to be a right angle. And so nicely we'll make that right triangle, which of course we have a lot of things that we can do with. Number 17 and 18, some more circle stuff, this time with inscribed angles. Just remember, if you have an arc and you take, like let's take AB for instance. If I take AB and bring those points anywhere in the circle, it's going to be half of what that arc is. So I know that this is 64 because double 32 is 64. I could bring these two over here and I know that this would be 32. So the same kind of thing happens here. It's just that same arc being brought to different points in the circle. So they would all have to be the same. And same thing for the second part of 17. 18, even more of these problems. Same as from problem 1 and way back. Two chords intersecting each other. 23 times 15 equals 23 times x. 6 times x equals 4 times 3 on either side of each chord. Like here's one chord. Just draw a straight line. The two parts of that chord, that should multiply to equal the two parts multiplied of the other chord. Right, these are popping up a lot. All right, last page. We'll get this done in one go. Assuming the prisms at the right are similar, some similarity on this test is coming up. So remember to find that scale factor from one to the other. We can take 8 divided by 6 to get you what your scale factor is. Otherwise, you could set up a proportion if you wanted to. So 6 over 8 should equal y over 10, your corresponding parts. So you can use that to solve for y. And you can solve for x in the same way. So taking 6 over 8, take that same proportion, 9 over x, because I know that this is 9, that's 9, so those are both going to be x. You can set up that proportion that way. Y is 7.5, x is 12. Ratio of the corresponding sides, you can just reduce that fraction. Otherwise, this is 1.3 repeating, or 1 1/3, kind of however you want to write it. You might even see it like this, 4 to 3. The colon just is the same thing as the division sign. But it's just saying the length of solid B compared to solid A. How much bigger is it? If the base is 27 square units, the base area of solid B would have to be, so we're taking 27 times the scale factor squared. Right, that scale factor from before, because it's area, you have to square it. Number 20, systems of equations. Part A deals with elimination. Since we have positive 3x and negative 3x, it becomes easy to just cross those out, add the two equations together to get y. Part B is more of a substitution problem. Since you have y equals something, I can just plug what that something is in for y in the other equation and get an equation for x. Number 23, a pretty difficult problem. There's a few ways to do it, and on this review guide, it's a different way than I did it on the review guide that's posted on Schoology, but you can get the same answer either way. But big idea here is you're taking your chord of 9 millimeters, splitting it into the central angle. Since you have an isosceles triangle, since both of those are a radius of the circle, you know that both of these have to be the same. Both have to be 74, and you can set up a law of sines to figure that out. It looks like that's it for me. I know it's a pretty abridged version with some help, of course. Yeah, now they're just pissed at me because I'm not playing with them. Yeah, all right. It's time to play now. But I hope you enjoyed this edition of Review Guide Answer Key Walkthrough as much as I did. And good luck.